but I'll link to it. But hi David.
Hey Daniel, sorry, I'm going video silent for a while here.
Oh, okay.
I'm on the
All right.
move.
Okay. I don't know if there's anyone who's attending. Oh, I actually did. I didn't officially start the meeting. I'm sorry. Now that there's this sort of claim host functionality, that was my fault. So welcome to the Provider Implementers office hours for January 15th, 2019, 12 p.m. PST. If you are attending, please add yourself to the attendees list in the agenda doc. And if you have any topics or questions, it would be great if you can add them there as well. And I will post a link to that doc in the Zoom chat right now. It's also in the Cluster API Slack channel, the Kubernetes Slack channel. Okay. I was wondering if there's anyone in attendance right now who is interested in the generic or a generic cluster API provider. So that is a provider that could be used across multiple environments. For example, environments that maybe have infrastructure APIs like GCP, AWS, or perhaps even an environment that doesn't have an infrastructure API. All right.
Can you give a little more detail on that? What you're saying?
Yeah, absolutely. So today, there are individual providers that are specifically tailored to environments. So, for example, there's an AWS provider, there's an OpenStack provider, there's an Azure provider, and these providers will bring up. They will call the respective APIs for those environments, and they will bring up infrastructure, and not just the machines, but also things like load balancers and maybe networks. But each of those providers is specific to that environment, and there are no providers, for example, that just target, for example, there's no provider that targets an environment where there is no infrastructure API. So that is, the act of creating a machine would be something that maybe an administrator actually, like a person, has to do. Whether like it could be booting a virtual machine, or it could actually be, I guess, like racking a new server and making sure it has an IP, et cetera, et cetera. Does that give a little more detail?
Yeah, that makes more sense.
So I can elaborate. I mean, I'm not sure to what extent I'm prepared to really dive into the details of this in the meeting, but this is something that's come up in the multiple times in the primary cluster API meeting, and the idea is, what if there were an alternative way to extend cluster API providers such that not everybody had to write an actuator, but instead you could use webhooks as a different extension mechanism. So historically, when you look at the providers that are the sort of the lowest common denominator, there have been multiple SSH providers that have been written, and they're all typically built around kubeadm and etcd-adm, things like that. And so the idea behind a generic provider is basically that we would like to be able to share the provisioning of Kubernetes on nodes, which are created somehow. But we would like how those nodes are created to be pluggable, perhaps with webhooks, so that multiple bare metal environments or multiple environments without shared or common infrastructure can use the same provider. And only the webhook mechanism that allocates the machines would differ depending on what your bare metal environment or your particular environment looks like.
I think that'd be beneficial.
Is there a specific use case that's important for you? So for example, some environment, maybe an environment where there are no infrastructure APIs, or maybe just like the ability to use the same provider across different public clouds.
Well, we're looking at different clouds all at the same time. So, I mean, where we were doing things before looking at Cluster API was doing a similar thing where we're trying to set up the same way to build our cluster on top, but then we were plugging in different ways to build the infrastructure underneath it. So I'm just kind of getting into this right now to see how I can help. And I think it's great ideas where we're going through thinking about this. So
I
don't
guess
have Go for it.
I was going to say, I guess my concern is around whether our mechanism for doing this is to write a new controller and whether we can make that easier versus a hook or something like that. In other words, why would we not just have a new controller for each one of these?
So that's a great question. And it's one of the two alternatives that I've considered. So after seeing your talk, Justin, another legitimate way to make it easier to write actuators would be to extend KubeBuilder, as you guys did with the add-ons as operators, such that there's a new pattern cluster API provider that could generate all of the scaffolding for you. One of the downsides of doing that is that KubeBuilder generates the code once. Actually, I guess maybe there are no downsides. You can still import some other library that can be updated. Okay, so I think that is another legitimate way to solve this problem. And so this is something that I've been talking to Jason about, because I also proposed the KubeBuilder extension mechanism. I'm curious what the advantage of webhooks are as an extension mechanism over actuators. And one reason might be that a webhook is easier to write. So even if KubeBuilder generates all of the scaffolding, understanding the operator model and level-based triggers, for instance, the entire infrastructure, that may be conceptually more difficult than understanding how to implement a simple webhook, right? A simple server request response.
That is probably true, although I would say we probably still have to explain to people that they have to make sure that their webhooks are idempotent type things, right? We still have to teach them some of that, but we can certainly help them do it. The other huge advantage of webhooks is that if you have a Ruby provisioning system, it is much easier to write a webhook, right, than it is to implement a webhook than it is to write a controller in Ruby.
Right.
But I would really like to see the variety of things that we're actually talking about in terms of the potential controllers, and it may be that we can deal with it on a case-by-case basis. But yeah, I'm not fundamentally opposed to putting a webhook, except that I don't understand why it would have to be or I think it could be done in a separate repo, in a separate provider.
Yes, it would be, not only would it would be a separate provider, but each webhook would probably be in its own repo too. I had a question about your experience extending Kube Builder. I've only briefly looked at doing that. How difficult was it?
There have been some repo or organizational challenges around figuring out where the code that extends controller runtime will live, which is, I think, the more challenging bit if you want to extend that. In terms of the framework for Kube Builder, I am not sure. We haven't actually pushed on getting that merged until we've got the other ones done. It's not, honestly, it definitely needs, it will be easier when the second implementation is in there, I think. It is not terribly extensible at the moment, or it's not designed for like, it's not like a full templating system. So we'll have to see where that goes. It may well be easier to create our own scaffolding type thing. We'll have to see. It has the potential. The implementation, because they only have one implementation at the moment, is not there yet. But it would be great to put in the work and help them get there. I don't think we're there yet.
I see. So maybe a more pragmatic question. How many man months did it take to implement the -- pattern equals add-on option?
Less than one. But we haven't got it merged yet. But it's not hard. The tricky bit for the add-on operators work was figuring, like, building the library itself, figuring out what that library looks like, the framework, the common functionality looks like, and then building that up. And mostly actually around requirements more than around implementing. Like, the code is not itself not terribly complicated. So if we feel like we have a better understanding of what a machine actuator implementation looks like, I think it'd be straightforward to do. And we could also create a skeleton project, right? It might be that there's not a ton of differentiation between that needs that much customization, right? That if we're just implementing an actuator, maybe it's not even that much work anyway.
Right. I mean, we did that originally back when the cluster API was based on the aggregated API server. And I think I actually did it for CRDs too, and I just never announced it. So it's certainly easy. It's certainly easy to create the scaffolding. I agree.
I think I have hacked up one myself, and I've done it in a single file. So it may be that it is like the scaffolding may just be overly complicated. Actually, that's not true. I think I did multiple files anyway. But we can look at making it easier. The provider spec is, I think, the tricky bit. So, yeah. Yeah, I guess putting it into Kube Builder would be the way to go. It might be that we say add these 5 lines, or it might be that we say we can put in a flavor into the Kube Builder thing and actually have it be a nice pattern type thing.
Yeah, this might be something worth revisiting during tomorrow's meeting.
Yeah.
Although I'll be curious to see how that meeting goes with so much of the group out of state. I had one other just real quick question that I think either Justin or Daniel might have an answer to. Let me add it to the agenda. So we're looking at managed control planes. In particular, we've been looking at the Gartner model, where they have a single etcd server, and it's run in a manager cluster with frequent backups and snapshots. So actually, the detail about a single etcd instance or multiple etcd instances, that's not the salient point that I want to ask about. What I wanted to ask about is, does the etcd ADM work will that allow etcd to be installed as a pod in a cluster, meaning not a static manifest? Or is that undecided?
I think it should. I don't think we've scoped it yet, but yes, one of the things Daniel and I have talked about is, so we have etcd ADM, the CLI, which is basically like the manual mode of operation. We have etcd Manager, which is what COPS uses to do it automatically. We're trying to get the automated mode building on top of the CLI so you can see everything. One of the ways we thought of when we were sort of brainstorming to put that on a firm foundation is to build an operator. So when you do it without the Kubernetes dependency, there's a lot of like weird magic that has to happen. But if we or I or anyone first build it as an operator, we can really clearly understand what it looks like in that model and express it that way. Hopefully that is much simpler. We install it on a pod, run etcd ADM in it if it's the first one, and etcd ADM join and copy the secrets around. But that will be something that we will certainly make a little easier. Yeah. I don't know if that answers the question.
It almost does. So when you say an operator, you mean like a Kubernetes operator, or
Yes, because so we're imagining three modes of operation. Well, so we have a mode of operation we know where it's manually driven by the CLI. We have a mode of operation where it's fully automated and like it relies on external sources of truth, like some cloud API to drive that automatically. And then the proposed second mode would be another more automated mode of operation where the source of truth is the Kubernetes API, which is an operator.
Right. Okay. Excellent.
So I just want to clarify, specifically in the Gartner model, where the control plane for a cluster, including etcd, runs in a different cluster. Everything has pods. Today, right? I think Gartner. I assume that Gartner uses the etcd operator, and is I think that if etcd ADM takes on so clearly there's a need for an etcd operator like functionality that doesn't require Kubernetes already running underneath. There's clearly a need for that. But in this specific model, where the control plane is running in a different cluster, I mean that you can take care of with etcd operator. So then the question is, what is the future of etcd operator, and does etcd ADM need to provide the operator like functionality, external of Kubernetes and internal, or like on top of Kubernetes, like replace what etcd operator does today?
That is sort of the question. I mean, should I be looking at using etcd operator as it is, or do we think that etcd ADM is going to also encompass functionality?
My view, and it's only my view, is that we should, in the etcd ADM project, create an etcd operator that uses etcd ADM, so that we have consistent operation and consistent backups and snapshots, and you can take it from bare metal and install it on a Gartner cluster or whatever it is, or Gartner to bare metal or Gartner to AWS and all these, and we have one sort of code path just because, or one broad code path just because it's a little bit tricky. And my understanding is the etcd operator itself might not be fully supported anymore.
Right.
I also think it will help our project etcd ADM on the automated side if we have an implementation that has a reliable source of truth. Like we can really get that behavior figured out and follow the patterns which are established, and then take those to the less reliable sources of truth, where it's but it's not going to be a ton of an etcd operator itself, with or without etcd ADM, is not a ton of code if you have Kubernetes, right? Most of the work is, I think, generating the secrets. But I do think we should use etcd ADM to do that little piece of work if we can.
I agree. I think I think in that scenario, Kubernetes, from etcd ADM's perspective, then Kubernetes is simply another source of truth plus API to maybe deploy new members, right? Where like it could be Kubernetes, or it could be, I don't know, EC2, where your source of truth is the list, list of instances reported, and then you can maybe bring up another instance to spin up a new member, or something like that. Is that kind of what? Yeah. Okay. Yeah. But as far as timelines, David, if you're asking, can you use it tomorrow? I don't think it's like it's going to happen overnight. And I don't think there's anything wrong with using etcd operator today, and then moving to etcd ADM once that functionality is there.
I would definitely chat with the Gardener folks about that. When I looked at the etcd operator, it had some odd behaviors around, like if you lost quorum, the behavior there, they may have fixed it, or they may not have fixed it. I don't know.
So that was my concern. My understanding is that the etcd operator was not actually highly available. Like there were certain failure cases that they could not recover from.
I think it's worse than that. There's certain failure cases where they delete the data, which is my real concern. Like I don't mind if the etcd cluster goes down, but like if they actively delete the data, that seems like a whole different game. So that's the one I want to double check.
Okay. Can we put that in the notes?
So they definitely double check. Like if you lose quorum, does it recover quorum by starting a new cluster with new data? But I'd hope that the Gardener folk actually, it'd be interesting to see what they've done. They may have written their own, or they may have fixed it, or they may have discovered that it has been fixed, or just report that everything's okay. But you actually said something interesting, Danny, which is like that it's clear that we need rely on the cloud. I'm actually like, the more I'm using this, the more I'm trying to like polish up etcd manager, the more I'm like, oh, it's such a pain. Like it would be so much nicer to just, the Gardener model where you have a single etcd API and you bootstrap from there. So in other words, if I have one node, I can bring up etcd on it, no problem, using etcd ADM. If I then bring up a Kubernetes control plane and schedule an etcd operator that is reliable and works everywhere, and if I can somehow make it that I don't die when my single node etcd goes away, then maybe we're okay. So that's the Gardener model, and that's my understanding of the Gardener model. It's my understanding of the cluster API pivot model as well. And so that's what I'm also like looking at that, but I'm still we need it to we could get COPS users from where they are today into the future, but maybe if the Gardener model takes off, we are able to just have the operator or more people use the operator or bare CLI than use other approaches. But again, we'll see. The transition will probably mean that I need the management layer, but maybe we use it as a transition to get people onto other architectures.
So one of the reasons I think that running etcd operator in a manager cluster is interesting is I think it removes one of the prime reasons for running etcd outside of Kubernetes. So one of the reasons to run etcd on dedicated hardware outside of Kubernetes is to avoid circular dependencies. Once you have a manager cluster and managed clusters, you've avoided the circular dependency. And so now you only have to confine yourself to worrying about reliability, which is something you always had to worry about anyway. So by running etcd as an operator with access to things like kubeproxy, it makes log aggregation easier, metrics collection uniform, etc. So I think that's one of the reasons we're interested in looking at a managed control plane model.
Yeah, I think it makes a ton of sense. I think the challenge is I think there are two challenges, which is about who manages the manager, which there are many solutions to. And then the other one is, does it scale down to small cluster sizes? So in other words, if I'm a COPS user or a Kubernetes user just kicking the tires, right? I don't particularly want to start a cluster to start my cluster, right? People are pretty cost sensitive at that scale, but you know,
in that case,
there are answers there as well.
Kind, right? Minikube.
Yeah, yes, and I think then that ties into the reliability question, which is how do we ensure that Minikube doesn't, or Kind doesn't act as a single point of failure, and that's where you get the pivot, or what Daniel and I were talking about at the very start, which is about like, can we get away with kubelet snapshots? Like I just need to play with that. I don't know if you've played with that at all. I'm sorry, kubelet checkpointing. I don't know if you've played with that at all.
No, I haven't.
In theory, it might take care of some, but not all of the failure cases. So like it would take care of the, I hit the reset button on my machine. Does my pod come back without the control plane? Like without a control plane, the answer is normally no, but with checkpointing, the answer should be yes. Now, whether kubeproxy comes back, I don't know.
I mean, even in the managed, or I get managed control or hosted control plane model, right? You still have the circular dependency. It's just for the cluster that hosts the control plane.
The cluster that hosts the control plane doesn't need to run its own etcd, right? Either it can use an external etcd, which is the traditional way to solve the circular dependency problem, or, and I think this is similar to what Gardner does, but you can also imagine having a ring of clusters such that everyone runs etcd, but no one runs etcd for themselves.
Yeah.
And the other approach is to figure out a way such that you don't care, or such that you bring up an ephemeral one, and that when it goes away, you are okay with it, right? So in other words, you solve the bottom turtle by saying the bottom turtle is temporary, and we have ways to bring up temporary clusters that are, Minikube, Kind, whatever it is. But that's, again, pretty tricky.
Oh, I see. So what you mean is that once you've, so for each time so let's say that you have a cluster that hosts control planes. Every time that you want to add another control plane or remove another control plane, make some kind of change to that cluster, at that point you have to bring up that cluster's control plane and storage plane. But otherwise, you can sort of bring those down and have those have those not be around, and rely on the checkpointing to ensure that once I've said that I want X number of whatever pods for some cluster to run here, an etcd to run here, just keep that going. So that'll work. And if but you'll need to bring up this temporary control plane every time you want to do something like scale or add or remove, right? Those kind of operations.
Yes, and it's about yeah. So you only the temporary control plane, you need it when you want to change the cluster with no support, and then or with no underlying turtle. But you know, by layering a turtle on the turtle, you can change the number of times you need to do that, right? Because the turtle that stands on a turtle is okay.
Right.
It's only the very bottom turtle that you have to like jerry rig type thing.
Right.
So you wouldn't, for example, let's think. If we ignore resources on that control plane, you wouldn't need to bring up the control plane. You wouldn't need to bring up the ephemeral control plane just to launch a new cluster.
Right.
But in practice, maybe you would, because you might run out of nodes in the. But you would definitely need to bring it up if you lost a node, right? In your, or if you wanted to upgrade that bottom turtle.
Yeah, I think the Gardner model, you know, whether it's the ring or whether it's this, you know, temporary cluster that we're talking about, it seems like there's quite a bit of complexity. Like it's not clear to me, you know, if like what is the worst possible failure, and how do you like, can you recover from that? Can you you know, even reason about it? Because as you know, as hard as it is to solve, I guess to you know, to solve the problem without you know, this sort of this ring idea or temporary control plane, maybe there at least, you know, you kind of understand what the path to recovery is. So I don't know.
I think we should. I definitely think that we should be very focused on what you've just described, right? Like when I do architecture 1 versus architecture 2, when do things go wrong, and when they do, what do I have to do? And I think that's absolutely the right way to think about it. It's also very sort of practical, right? Like we can actually like divide and conquer that one and like think of like the different failure modes. And I think that honestly I think that the two approaches we are working towards, like I feel like we're working towards one with, or 3 approaches. I guess we're working towards like the ephemeral control plane which goes away, the ephemeral control plane which pivots, and then the like etcd ADM where it like brings up a normal like traditional all-in-one control plane. I feel like they're all fairly easy to reason about and think about. We can come up with a list of things that can go wrong, and I think that they are reasonably bounded. But yeah, I definitely agree with your approach of like what are the failure modes and what do we do. That feels like more of a topic for tomorrow.
Oh. This I didn't get a chance to add, because I learned a lot about the Gardner model at that HA meeting that happened. That was in person at KubeCon Seattle. But one of the things, I think it was Tim Sinclair, or actually no, it wasn't. I'm trying to recall. Yeah, I guess I had a question. I don't remember if I got to ask it actually. You know, if actually wait, David, it was your question. You asked it. You know, the Kubernetes API is becoming a you know, place where some critical add-ons live, right? Critical add-ons that use CRDs, or that just, you know, need access to existing objects like Istio, for example, right? If you, in the managed control plane, you have, you know, you're able to lose the control plane you know, due to some network problem, where, you know, whereas like all the infrastructure that your kubelets run on is fine and intact, but you've lost the control plane due to some network issue. Is that like is that a single point of failure? Is there a way to work around that? Like, do you set up redundant network links? Is that how you deal with it? Or, you know, what?
Yeah, I don't believe that that we require like cross-regional, like, I think the answer would be that you would run your management control plane in your same zone, or even VPC, or zone and VPC in AWS land, as you would your like actual cluster. And I think there's a trade-off between, I want to put it right by the resources that I am managing, versus I want to run, you know, I actually want to run my control plane on GKE, even when I'm on, you know, like even when I'm on bare metal, right? Which would be easy for everyone to do, but then you're magically depending on GKE, and like, yes, as you say, like cloud connectivity is a tricky thing.
Well,
so there's probably somewhere in the middle.
Sorry if I'm a little noisy in my current environment, but so the observation that Daniel was recollecting was that as more and more operators are written using CRDs, historically we've said that, you know, it's okay if the control plane goes down because your applications will continue running. And the observation is that as more and more applications are written using CRDs, it could be that it's no longer true in some environments or some applications to keep running when the control plane goes down. So for instance, the cluster API, if you view that as an application, which it's not, maybe, but you could imagine some other application based on CRDs. It could be that for some applications, the control plane can't go down, and an HA control plane is absolutely required, in which case the Gardner model of a single etcd server and then fast recovery, it may or may not suffice. It would just depend on how fast you can recover, because it may be the case that you could never tolerate the control plane going down, or you do have application observable failures.
I would hope. I don't believe that the Gardner model requires a non-HA, a single node etcd, if you know what I mean. I think you could run HA etcd in the Gardner model. To me, the Gardner model is running your control plane as pods, or for example, as etcd as a stateful set. And that stateful set could have 1 or 3 members, or 5, or pick your poison, right? I think there's definitely we have to be careful that the Gardner model with the bottom turtle doesn't like make that 3-node stateful set actually like completely unreliable. I don't believe it does, but we have to be, you know, double check that. And we have to be careful that if you're thinking you're going to run your control plane in a cluster that is on totally separate hardware, that you're going to have a whole new set of failure modes, which we haven't thought about. But I think you can run etcd as a 3-member stateful set, and I think across 3 zones, and I think you could run your control plane in the same, even on the same pool of bare metal machines, for example, even if they are logically isolated, logically separated. And I think you should do that if you care about like that networking mode of that networking failure mode. I think it's a good point. Like, although our controllers today are very nicely written and glide, as we make it very easy for people to write controllers, we might expect that standard might slip. And KubeBuilder pushes you in the right direction, but I don't think it. I'm sure there are ways to mess it up.
Does you know how we removed the role from the node, you know, this whole notion of master and node. There was a visit, I think it was Tim Hawken maybe, who dropped into a meeting many months ago and said, hey, you know, move away from this model. And now I'm like, in the context of this managed control plane, hosted control plane, I kind of see that there is this node, right? Because there are, I guess now it's in a separate cluster, but basically it's not like that it doesn't look like all nodes are are equal. So I don't know.
So this is when we were doing the backlog grooming for V1 Alpha 1, I picked up a couple tasks related to better documenting the semantics around the link between clusters and machines and the link between machines and nodes. And roles are another one of the areas where I think we need to do a better job of codifying the expectations. So I think that's something that we need to document. I think Tim Hawkins' observation that there are environments where roles either don't exist or there are more roles, or at least there may not be a common set of roles between providers, right? So for instance, internally, we have a use case where we have a proxy node role. And that's not generic. So that's never going to be part of the common code. Now that said, I do think we need to provide better guidance on how one determines if a node is a master or a worker, because even if there are many environments where there is no distinction between nodes, there are also many environments where there is a distinction. And I think we need to have clear documentation and guidance on how that distinction is conveyed so that higher level tooling has a reliable way to make that distinction. And so Tim Hawkins' point is an important one. And I think what's happened is we just haven't gone back and actually decided, you know, how do we incorporate the idea that maybe roles may not exist, with the fact that when they do exist, we need a common way to determine what the role is. And that's one of the things I would like to clear up for V1 Alpha 1.
I agree with that. I think that's a great topic maybe for tomorrow in the general audience. I think one way we may be able to tackle it is by thinking through sort of the implications, like, you know, does this affect cluster autoscaler, where we don't want it to like scale a master when it has to be on a node, or vice versa, or the proxy when it should be a master that's scaled. And I think I agree with you that it is unclear. I think Robbie has some ideas as well around, so we should see what he wants, what he proposes.
Yeah, so originally Vince, he opened an issue talking about splitting up the control plane provisioning from the cluster actuator. And initially I was like, I don't understand why. But I think that this would be a good reason why. If you had a different actuator for worker nodes, for control plane nodes, then you wouldn't need a concept of role, because the actuator would implicitly determine what the role was. And yeah, that's just one of the ways to solve the problem.
we should at least figure out whether roles is I am a master or I am a node, whether it's an exclusive enum or a enum set or a open-ended like set of effectively like label or tags, right? So it's fine for you to put in proxy, even though no one else knows what proxy is and it only has meaning inside of your cluster or set of clusters. But the point is that a proxy is not a master, for example. Like we should figure out those semantics if we keep the roles field.
Well, we deprecated the roles field already.
Oh, okay.
And so so I see like two, and I'm not, there's so many things to talk about tomorrow. I'm not sure which ones we'll get to, but in terms of roles, I think there's sort of two ways that I see. And one is to follow the KubeADM model of using labels and taints. And the other is to have a different cluster API type and actuator, which is explicitly for control planes. And in that case, we don't even talk about the role problem. That's like if you need a proxy role or something else like that, you can use labels, taints, you can do whatever you want. But for the purposes of standing up a Kubernetes cluster, the worker and control plane role distinction can be solved through types, or right now what KubeADM does, and that's taints and labels.
And those taints and labels would effectively be the taints and labels that are applied to the node, and we would effectively say that those will define the node taints and labels will be what defines the roles, which is nice because it then means we can use workload placement, workload tolerations and labels, node selectors, right?
Yep.
Right. The challenge, I think, is sorry.
No, go ahead.
I was just going to say, I don't know if the issue is still open, but the idea of standardizing those labels and taints has been a long-standing point of contention, which I think we just need to drive to completion and say that these are the labels that we're going to use. So that although everyone has agreed, although almost everyone has agreed to use the master label and master taint, and you are on your own world if you don't, they are not technically part of the Kubernetes API.
Right.
Even though people utilize them.
so that's I'm talking about the same issue that you are, and I think it's still open. And I think the way that we resolve it is through documentation. Right.
Yeah, I would love to see it resolved. I don't know how we can go about that, but yes.
Are you making some changes somewhere, or if you are, you can add a link or no? Oh, okay. Sorry.
I was not sorry.
Okay. Yeah, we're almost out of time, so I just want to see if I guess we're still talking about node roles. I don't know if is there anything else? So let's see, Bryson, if you're still on the call, I was wondering. So I think you briefly mentioned to just the coming back to the generic provider. Do you have a use case for I guess sort of bare metal or some environment where well, bare metal where maybe you have, Pixie booting or maybe even, no infrastructure API whatsoever, where, some administrator or some person is going and racking, machines and making sure that they have IPs. And then, you want to be able to use those in a Kubernetes cluster, or, somehow use those using the cluster API. Or do either of those use cases apply to you? Okay, maybe he's not. Maybe he's not on. Okay. So I just wanted to get that question in before the end. Okay. Is there sorry, is there anything else that we want to discuss before we wrap up for today? Okay. So just so then tomorrow, is someone going to add the node roles to the agenda? Is that something that you want to discuss, Justin, or do you want David? Is that just want to maybe so we don't forget? Maybe we can add it to the agenda for tomorrow's cluster API, the general meeting, or anything else for that matter. I don't know.
I'll check if there's an existing ticket for node roles in the cluster API repo, and if not, as an action item, I can open one and then link it to the existing KubeADM ticket on the same subject.
Okay.
I'm not sure. First, I don't know what attendance is going to be like tomorrow with FPO out and everything else going on. My goals for tomorrow are probably going to be. I have a bunch of other, so I think one of the main things that we're going to want to talk about tomorrow is really the drive towards V1 Alpha 1. There have been some grooming meetings, not everyone's attended, so I think that at least a sort of a status report on that is going to be necessary. And then my own personal goal is to start chipping away at those goals. So clarifying things like link between clusters, machines, etc. Node roles is on the list. I just don't know what priority is.
Okay. Fair enough. All right. Excuse me. All right. Thanks. Thanks everybody for lively discussion, and we will see you either tomorrow or next week. All right. Have a great rest of your day.
See you guys. Bye.
Bye.